Okay, it's a classic question. We're going to begin with a question. We're going to begin with a guess, all right? This is going to lead us into geometric sequences, and hopefully by the end of the day, we'll have this all figured out. Okay, so I want you to guess. Look at this picture. I gave you some fractions in there. I'm asking you for what percent of this picture do you think is purple? And I'll take your guesses. I'll just write them down.
2/3.
Percent. We're going for percent. I have a 33%. I heard 66% out there in the audience. I heard a 50% out there. Any other guesses? Huh? 20%. I heard 20%, and we'll take one more. Anybody got another one? 40%. Okay. Wait. 33. Yeah, we got 33 on there. So these are our guesses. All right, cool. Okay, we'll do 25, and that'll be it. Okay. So we think that our guess is somewhere between 20 and 66%. That's our range. You guys agree with that? Is that our range? Okay, so we're going to be talking about geometric sequences today, and the first thing that we're going to do is actually take a look at a geometric sequence. And there's one right there that happens to be here. 1, 5, 7, 125. Okay, so my first question to you guys is, why is this sequence... Wait, what did I do wrong?
1, 5, 7, 125.
I said 7? Oh, sorry. 1, 5, 25, 125. I don't know where the 7 came from. My first question for you is, why is this sequence not arithmetic? Why is it not arithmetic? Toby, what do you think, dude? Yeah, there's not the same change, right? Because if I take, remember, arithmetic sequences, if I take any number in my sequence like 5 and subtract off the previous one, I get 4, that number should remain constant throughout. So 125 minus 125, or 125 minus 25, that's not the number 4, so it's no longer arithmetic. But there is something that is going on. Does anybody see what's going on? Yes?
Constant multiplication.
Yeah. To get from here to here, what do you multiply by? Multiply by 5. From here to here, what do you do? Multiply by 5. From here to here, what do you do? Multiply by 5. And then you just keep going, right? So this is an example of a geometric sequence. So it is a sequence with, instead of a common difference like arithmetic had, this one's going to be a sequence with a common ratio. And we're going to call that ratio r. So how do we get this common ratio? Well, we pick any term in the sequence, like this one, 125, and we simply divide by the term before it. So 125 divided by 25 is 5. 25 divided by 5 is 5. 5 divided by 1 is 5. There's that constant 5 that's in between there, right? And the only thing that we need to know is that r is not allowed to be the number 0, which makes total sense because I can't multiply by zeros anywhere and get that. Okay, so this is going to be our general example of an of a geometric sequence. You guys cool so far?
Yes.
All right, let me give you some more examples. Same box. Let's see if you can tell me what the ratio is, okay? So how about this one? 4, 8, 16, 32, and 64, ... This is geometric. Can you tell me what the ratio is? 2. Very good. You just pick any term, like 64, and you divide by the one before it, and you get 2 every single time. Here's another example of one. How about 6, negative 12, 24, negative 48, 96, ... So what do you think the ratio will be here? Negative 2. Okay, so far, ratios are allowed to be positive numbers. They're allowed to be negative numbers. And in this case, I'll give you another one. Take that 9, negative 3, 1, negative 1/3, 1/9, ... Yeah, exactly. The ratio is equal to negative 1/3. Can I ask you how you got negative 1/3 out of this? What did you do?
Well, it was going down. I mean, like, if 3 is 1/3 of 9.
Yeah,
And
so
it's negative.
yeah, pick any term. 1 divided by the term before it. 1 divided by negative 3. There's your ratio every single time, right? Pick any term divided by the one before it. That will give you your common ratio. Okay, so I'm asking you to write out the first 4 terms of a geometric sequence here. Okay, so I like how people are taking on this approach of, okay, let's write out my sequence here. Right? A sub 1, A sub 2, A sub 3, A sub 4. And what do we know? The very first term is the number 6. Okay? So how do I get the next term? If the ratio has to be a third, what do we do?
2.
Yeah, we multiply by a third, right? So 6 times 1/3 is a value of 2. So the second term is 2. The third term would be what? 2/3, very good. The fourth term would be what? 2/9, right? Because 1/3 times 2/3 is 2/9. And then just for the heck of it, what would be the fifth term? 2/27. Very good. Okay, and then dot dot dot. It would keep going. Okay, so let's develop here the general term, or the a sub nth term, also known as the fast forward formula. Okay, so I have a sequence here, and I have a geometric sequence. Is that true? Okay, what is my common ratio? 2, right? So I'm starting with 5, and I'm going up by multiples of 2. So 5, then times 2 is 10, times 2 is 20, times 2 is 40, times 2 is 80. So far, so good? Okay, I'm going to rewrite this for you in a different way. I'm going to rewrite the terms for you. So this is still going to be a sub 1, this is still going to be a sub 2, this is still going to be a sub 3, still going to be a sub 4, still going to be a sub 5, dot dot dot. Okay, the very first term is 5. You guys agree with that? So it is 5. We cool with that part? Okay. And I'm going to write the ratio in here as the ratio we found out was 2. But in order to keep my first term, the number 5, what exponent does the 2 have to be? What? No, not 1. You're close. 0. How come? Why does this need to be a 0? Because 2 to the 0 is 1 times 5 is still 5. Okay, good. I'm doing this for a very specific reason, and I hope that you see it. Okay, the second term, the number 10, can be rewritten as this. 5 times 2 to what power? To the first power, right? 10 is the same thing as 5 times 2 to the first. Okay, interesting. The 20 can be written as 5 times 2 to the what power? Squared, yes. 40 can be written as 5 times 2 to the third power. And then just for the heck of it, 80 can be written as 5 times 2 to the fourth power. Okay, I really hope that you see a few things here. And can anyone tell me any patterns that they are seeing or noticing right away?
The end value is 1 less than the
Okay, let me start that one. Yeah. So check this out. Yeah, this number here is always 1 more than that number there. Like 2, and then there's a 1, and then there's a 3, and then there's a 2. Does everybody see this part? Okay, so remember, the goal of this little exercise here is to build this term here, the a sub nth term. So you guys are telling me that the exponent is going to be always what? N minus 1 in the exponent. I love it. You guys are putting this together. Okay, great. Now, what else do you see? What else do you notice? Okay, yeah, there's always this 2 here, right? This 2 is everywhere. And what do... no, there's no difference now. You're close. The ratio, right? The ratio is always raised to our exponent here. So there is a ratio here, right? So R. Okay, and then there's something else that's in every single... A1. There it is, man. Nice job. There's a 5, right? Well, a 5 is the very first term, right? Oh, check that out. You guys, you have just figured out the formula for any term. A sub n is a sub 1 times the ratio to the n minus 1. You guys have just figured out the fast forward formula, also the general term formula for a geometric sequence, okay? And I didn't do anything. I just guided your thinking. Okay, here's a very typical example that I could ask of you. I'm telling you that in your sequence, the very first term is -4. There it is right there. It's given to you, okay? And the ratio is -2, and I'm asking you for some term down the line, a sub 8. So it's the fast forward formula. No problem. Well, here we go. A sub 8 has to be a sub 1 multiplied by the ratio to the 7th power, because always n minus 1. Well, okay, the very first term was given to me as -4. The ratio was given to me as -2, and I raised that number to the 7th power. So calculator would be good here, okay? So how much is -2 to the 7th power? How much? Yeah, so I have -4 times a -128. Multiply those two together, and you get a positive 512. So check that out. We can fast forward all the way to any term in the sequence that we want using that general nth term formula. Okay, official, you try. You and a buddy, try this one. The very first term is 5. The common ratio is -3. I would like the 10th term, and I will demand that you not brute force it all the way up, okay? Don't brute force it. Don't be, what's the guy in Popeye? Bruto. Bruno? Do you guys watch Popeye? Is it Brutus? Brutus. No. What is the evil guy in Popeye? The big guy. Is it Brutus? I don't remember. Okay, don't do that. Be smart. Okay, ready to go. Okay, so ladies and gentlemen, here is what I would expect to see on a test or a quiz or on your homework. When you write the formula out, we have a sub n equals a sub 1 times r to the n minus 1. I'm just showing you what's possible. A sub 10 equals 5 times -3 to the 10 minus 1. Huh? Okay, so you should write all of this, the highlighted part. You should definitely have all of that, at least, at the very least, shown. Okay. Okay. So write the general term a sub n. Okay. So what I'm looking for here is here's what we know. We know that the very first term is 3. The very second term is 6. The third term is a 12. The fourth term is 24. The fifth term is 48. Blah blah blah. I'm looking for the general a sub nth term. Okay, that's what I'm looking for. Very simple, very straightforward. So what we're going to do is we're going to write down everything that we know about geometric sequences. We know this. A sub n is equal to a sub 1 times r to the n minus 1. My answer, you guys, will have an n in it because I'm looking for the general term. So it should have an n in it. So therefore, a sub n is going to be the very first term, which is 3. What's my ratio? 2 to the n minus 1, and you're done. Okay, here we go. Just like arithmetic sequences, you guys, just like arithmetic sequences, we are sometimes interested in the sum of the first n of them, like the first 20 or the first 30 or the first 80. All right, and we have a formula for that. We also have a very similar formula for the sum of a finite geometric sequence. So finite means it ends somewhere, okay? So let's explain all these parts to you. The sum of the first n, so this means the number of terms we're adding up, okay? Number of terms. I'm going to move this up so I can see this. Terms we add up. So like the sum of the first 30 or first 40, n would be whatever that number is, okay? What does the a sub 1 represent? The very first term, very true. The very first term. Okay? What does the r represent? Your common ratio, very good. Okay, do you notice that this n here on the exponent on the r is the same as the exponent or the subscript down below? So those two n's are going to match. So I'll highlight those for you so you can see that whatever number's down here is going to match with that little exponent up there. Notice that the n is on the inside of the parentheses. It's not on the outside. And then what does this r down here represent? Well, it represents the same thing. It's the ratio. Okay? So now we have a nice little diagram. It's full of colors of everything that we need to know about that. So let's do an example of this one, okay? Yep. Here we go. Okay, here's an example that there's no way we could do this by hand. So this would take us forever, right? So we want the sum of the first 18 terms. So I'm going to move this up. I will come back to it, though. So this is saying, 2 plus -8 plus 32 plus a -128 plus yada, 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 all the way down for the 18 terms of this thing, right? Okay, so we need to apply what we have. Here's what we have. We want the sum of the first 18 terms. You guys good so far? Okay, good. So it's going to be the very first term, which is what in this case? 2. Very good. We're going to go 1 minus the ratio. Now, what is the ratio? It's -4. Very good. So I'm going to raise -4 to what power? To the 18th power. Very good. And then I'm going to divide by 1 minus -4. And that's just straight up from the formula up above. Okay, that's all I did. So I rewrote it so you guys can see it over here to the right. Okay, the rest from here is calculator stuff. Okay, it's calculator stuff. So we're going to go 2 times. We need to figure out what negative 4 to the 18th power is.
Scientific notation.
So what is negative 4 to the 18th power?
6.871.
6.87 times 10.
Okay, so let me show you how to plug this in correctly, okay? Whoa, that is a giant calculator. Okay, so I wonder if there's a way I can not make this so big. Okay, here we go. Let's do that. Let's bring this over here. Okay, I'm in the wrong spot. So here's what we can do, okay? We can go negative 4, so in parentheses, let's go negative 4, all right? And we're going to go to the 18th power. You guys follow along? Push enter, and you get some horrific thing like that, right?
Yeah.
Okay, don't worry about it. Just leave it there. That's the cool thing about calculators. We don't need to know what that number is. The calculator will solve it for us.
Oh, wait.
So watch this. Very, very cool. We're going to go 1 minus second answer. Oh, very good.
Where's the end?
There we
Where's the
go.
answer button?
So you know what that does? That says 1
Oh,
minus.
second entry?
Yeah, second entry. It's second entry. Or sorry, second negative. Yeah, right there. Do you guys need me to do that again for you? Okay, all right, no problem. Watch. Negative 4 to the 18. Push the enter button. Okay. Now, whenever you push, watch this. I got 1 minus second negative. That puts the answer that's stored in the calculator right there on your screen. Then you push enter. Well, that's our whole numerator right there. Oh, that's cool. Now we need to divide this. Watch this. Just push the divide button. Oh, yeah. Multiply by the first number, which is the first value, which is 2. Very good. So now we have that number. Okay.
So now you multiply that by 2.
Okay. Then we need to divide by what?
Negative 3.
By 1 minus negative 4. That'd be the number 5. Let's divide by 5.
Nice. Oh, hey, that's why.
Hey, there we go. Okay. Negative 2.74877 times 10 to the 10th power.
That is a very, very small number,
No, that's a huge number.
but it's negative.
Yes, it's yeah, okay. That's what you mean by that? Yeah. Very good. Very good. Very good. All right. So, I'll write this out for you. It is negative 27. It was 487 790 694. So look. No. That's what the times 10 means. Look. See, check it out. Yeah. So look.
Bill Gates got more than that.
Hey, why'd you hide?
All right, these last 2 boxes are kind of abstract, and that's okay. So here's the deal. If your R value, your ratio, is trapped between -1 and 1. So that means your ratio is some kind of a fraction between -1 and 1, like 1/2 or -1/3 or something like that. If this is the case, then we can actually figure out a sum to infinity, which is a weird thing to think about. So let me give you a kind of a concrete example to the best of my ability, okay? So let's say I start with the number 10, and I say that my ratio is 1/2. What would my next term be? If my ratio was 1/2, I start with 10. Yeah, it would be 5, right? And then what would it be after that? Yeah, 5/2, exactly. And then after that, what would it be? 5/4, and I would keep going like this, right? So if I wanted to add this up, because my ratio is between -1 and 1, and even though I go to infinity, this will still add to a number. That's the crazy thing.
The other's small.
Yeah. It only works if your sum is between, if your R is between -1 and 1. Okay? Because the numbers get so significantly small so fast, the series actually converges to a number. So we're hovering around calculus right now, but that's okay. What we really want to understand is how simple this is. The sum to infinity is just the first term over 1 minus the ratio. That's all it is. It's the most amazing thing that I could ever come across in mathematics.
The most amazing thing
Yeah.
I've had. What does that abbreviate to?
In the pre-calculus, I think this is the most amazing thing right here, okay? So this only works. This is the caveat, you guys. It only works if your ratio is between 1 and -1. Otherwise, we cannot add to infinity, right? But because we have that special R, we can. So how does this Taya with anything. So remember this formula right here. Can you guys remember that for me? Okay. Watch this. Let's go back to the very front.
Oh my gosh.
Okay. Boom. Remember I told you?
It's 40%.
Okay. So check this out.
Oh, let him do it.
Okay. What's the area of this purple thing right here? This represents 1/4 of the area. You guys agree with that?
Yeah.
So I'm going to add up 1/4 plus. Well, how much is this right here?
1/4.
Well, that's 1/16.
Oh.
Plus 1/16 plus. Well, how much is this? That's 1/64, right? Okay. Plus all the way until infinity. That's what this means, right? All the way to infinity. Well, the sum to infinity would be the very first term over 1 minus the ratio, which is the very first term in my sequence was 1/4 over 1 minus 1/4. Well, that's 1/4 divided by 4/4 minus 1/4 is 3/4, which, oh my God, is a third, which is exactly 33%. Who guessed it at the very beginning? Yes, there you go. There's my bright ones right there. I love it. Nice job. Very, very good. Okay.